Assalamualaikum warahmatullahi wabarakatuh. Okay, in this video, I will cover matrix operation that involve arithmetic operations and inverse matrices for 3 by 3 matrix. Okay, we start with matrix operation. So when you come across additional and subtraction of matrices, you have to remember that the matrix have to be the same size. Okay, the additional or subtraction matrices is defined only for matrices having the same order. Okay, and in this case we have matrix A and matrix B, so it has same order, 2 times 2, and 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 uh, and then we can add the matrix, okay, as shown on the screen. All right, so every terms in the matrix we can add together. Okay, the additional of matrices is commutative. It means that when we add a matrix A with matrix B, it is equal with matrix B plus with matrix A. It is also associative. All right, A plus B and then we plus with C is equal to A plus B plus C. This one we did earlier. This one we did it earlier, but we will get the same answer where A and B and where A, B and C are in the same order. So you have to remember additional and subtraction of matrices must be in the same order. Example, if A, all right, if A is -2 for O, 3, -5, -2, it is 2 by 3 matrix, and then this one is matrix B. Okay, matrix B is 1, 3, -9, 2, 2, -5. So as we can see, it has both have same order, so we can add the terms together. And then the second example is subtraction example, and then the order, we have to make sure the order is the same. So when we look at this, okay, the matrices have the same order, so we can find the final answer. All right, for scalar multiplication, if K is a scalar and A is a matrix, then the product of K and A is denoted by Ka, which can be obtained by multiplying every element by element of A by K. The number of K is called a scalar. It means that when we have a whole number or any real number, and it can be multiplied with any matrices, how to do it is by by multiplying every terms in the matrices with the scalar with the scalar. So we can see the example as shown on the screen. If A is -3, 0, 4, and 5, find -3A. It means that matrix A, you have to multiply with -3. So every element in the matrices, you have to multiply with -3, and you can get the final answer. Okay. Okay, for multiplication of matrices, it can involve two matrices at one time lah. And then multiplication of matrices is the product of a row and a column matrix. The product of 1 times n row matrix and n times 1 column matrix is 1 times 1 matrix given by this one. All right. Alright. what I can say, when you do multiplication of matrices, you have to make sure that this one it obey. If A and B are two matrices such that the number of columns in A is equal to the number of rows in B, then the product of two matrices A and B denoted by AB is a matrix whose element in the I row and j column in the sum of the products formed by multiplying each element in the I row by the corresponding element in the j column of B. Okay. In simpler words, okay, if matrix A you have order m times n order, and matrix B you have the order is I times j. Okay, so you have to make sure that the column of A, this one, is equal to with the row of B. Okay, it must be equal. So when this is when the column of first matrix is equal to the when the column of the first matrix is equal to the row of the second matrix, so it means that we can multiply the both matrices, and then we can get the new matrices A, B, and the order is m times c. Okay, so how to do the multiplication process? It's like this. Okay, we have to multiply a row by column. So the first row have to multiply with the um, first row with the first column. So this is 1 1, so we have to put in here, multiply and then add, and you can get the summation, and that is the value of that term. Okay, and then the first still the first row, and then you have to multiply with the second column. Okay, so it is 1, right? First row and the second column, so we have to put in A12. Alright, so the elements of A11 we get from first row and the first column, and the elements of A12 we got from first row and the second column. Alright, so another row and the columns is same like that. Okay, matrix multiplication is possible only when the number of column in the first matrix is equal to the number of row in the second matrix, like I said before. Okay. Okay, when we come out with the topic inverse matrix for 3 by 3 matrices, it is a bit a longer step rather than when we do inverse matrix for 2 times 2 matrix. Okay, so the first thing that you have to remember is the step how to get the inverse matrices. So I have told you before that we have about 5 steps to get the final answer of the inverse matrices. The first one is we have to find the determinant, and then the minor, cofactor, adjoint, and then the final one is the inverse matrix itself. Alright, so the another method is using row operation methods or Gauss-Jordan elimination method. That is another topic, but then you have to focus first how to use the determinant method. Alright, so how to find determinant? when we use 2 by 2 matrix, we know that determinant value is AD minus BC. All right. But when the matrix is 3 by 3 matrix, uh, it is uh, it is the same. It's still AD minus BC, but it use deleting a row and columns of the particular of the first row element. Okay. Uh, so let's see the example. The determinant of a 3 by 3 matrix is okay, A, B, C, D, E, F, G, H, I. All right, so it's more than 4. So how to find the AD minus BC? Okay, first thing first, you have to take out the first row, A, B, and C. So the first A is positive, B, you have to put it in negative, and C is positive. So positive, negative, and positive. All right, positive, negative, and positive. Okay, and then when we want to find the AD minus BC for A, so you have to delete the first row and the first column. So it left out EFHI. So that is the ADBC, our new AD and BC. Alright, so you have to use the cross product. So EI, okay, E times I, H times F. So EI minus HF. So A times EI minus HF. Okay, minus B, and then B, how to find the AD minus BC for B? So B is still in the first row and at the second column. So it left out the D, F, and G, I. So that is the new ADBC, our new ADBC. And then next you have to find the ADBC for C. Okay, and then just uh, expand the bracket and find the value of the determinant. Okay, what is minor? So minor is for a square matrix. The minor Mij of an entry Aij is the determinant of the matrix formed by deleting I row and the j column of A. So the step is still same like how to find the determinant. Okay, but then we have to find the minor cofactor and adjoint for every element in the for every terms in the matrices. If you want to find the inverse matrices, so the first thing first is if you want to find the minor of M11, it means that we have to delete the first row and the first column. So we got the value of M11. So if we find the minor for the whole matrix, so you can get the it is how it looks like. But then when we get the minor, we actually can also get the cofactor. Okay, how to do the cofactor is by times the value of the minor that you get earlier with -1 to the power of I plus j to the power of I plus j times mij. Alright, so this is what we can get. Okay, the first value is from minor, but then you just multiply with positive, negative, positive, negative, positive, negative, positive, negative, positive, so you can get the cofactor of the matrix. Okay, the step is still the same by using the deleting row and column of the terms. And then when you get the cofactor, okay, the adjoint is actually the transpose of the cofactor. Okay, what is transpose? You have to turn the row into column or the column into row. It is a very simple steps to get the adjoint. So when you already get the determinant and then the final adjoint, so you can get the inverse matrix. Alright, so just put in the formula. So inverse of matrix is 1 over adjoint, 1 over determinant times adjoint A. So you can get the final answer of the inverse matrices. Okay, so this is a very short and quick video, so for your revision, and so I hope that it helps you to remember back this topic, and then so happy revisions, and thank you.